Okay. We will pick a goal. I was thinking of maybe doing the delay elements. Yeah, we can do the delay elements. The other things on the table are the input-output elements, which I haven't even drawn yet. Oh, actually, here's something that I've been meaning to do. So let me go over here, go in here, change this to be this. Okay. Now, I think there's a way you can add a menu item or something. Yeah. I think I want to use a menu item to change the simulation speed. So let's try it. I guess it'll go inside of init, which I don't think I have right now. So you do menu item index. I guess put it as 1. Index should be 1 through 5 and determines the order each menu item is displayed. Label should be a string up to 16 characters long. I think this was supposed to be a list, but the formatting got goofed up. Call it test. Function is called. Okay. We will do log you activated my trap card. If the callback returns true, the pause menu remains open. The callback takes a single parameter that is a bit field of LRX button presses. So we can use this to turn sim speed up and down. Oh, wait, how do I show the pause menu in like dev mode? Okay. I think I can just type this. That's strange. Oh, I see. Enter. Oh, there we go. Attempts to index field blah. Ah, okay. Fascinating. Wait, let's put in a separator here. Pause it again. Now if I just hit enter, it'll just go once, but if I hit enter and then I do left, right, enter. Fascinating. So it does it automatically, if it doesn't close on left, right inputs. Okay, we can do this. We will have a global called something like sim speed equals 1. This is number of frames per update to state elements 0 to pause simulation. This will be a nice add. Actually, let's do 0 for single step mode. And yeah, okay. So now in the draw function, actually, I have been wondering, like, is it possible to have really fast simulation? I mean, we could do something here where, so on every simulation tick, so this update the drivers is really only necessary after the state changes. Now the reason to, all right, let's do an experiment here. Does this still work? I think this does still work. Whoops. Oh no. Attempt to perform arithmetic on field state, a nil value. So that's why that was there. Okay, I think the solution here is when we create a net. Is we will give it an initial state, always. Same thing for gates. Oh, we already did that, luckily. Oh no. Uh-huh, uh-huh. So for a single frame, I don't know if OBS will have picked that up. I haven't actually watched back any of these streams at all until yesterday because I realized that I've just been flying blind of how they actually look and sound. Luckily, the sound balance is decent. I can't really do much better with what I have because this. Well, actually, that's not true, is it? I could turn up the gain in OBS, but I'm looking at the volume bars on OBS, and I have it set right now. We're at my normal volume. It's getting close to the red, but not going into it. So I think I better leave it here. I could turn it up a little. Let's try this. Oh wow, actually I can turn it up a lot. Let's leave it at -1 dB. Why not? What happens if I just put it up all the way? You know, this is interesting. I think maybe my webcam must have some kind of audio compression in it, or there must be some audio compression somewhere. Anyway, so yeah, here, what's the problem? We erase it in the update function. Yeah. We erase it in the update function, which causes all of the states to get guffed up. Well, maybe we could, now we're really starting to get crazy here, but maybe here when we create the new net, flipping here, call the DFS, found net neighbor, make new net from R, and return gates. I think if I do c.state, it'll fix that. So yeah. Maybe not though. No. I mean, we can keep this. There's no reason we can't keep it, but it was better the way I had it before. It was better the way I had it before. Now, there was a reason why I was doing this. Because these two steps back to back are what we would need to do if we wanted to simulate but not necessarily redraw. Like for example, if we wanted to turn on like some kind of insane turbo speed simulation, if we wanted to turn on some kind of turbo simulation, you know, we would want to run those two steps in like a loop on every frame. Okay, now here's a question. Do we want to update the state elements? No, I don't think so. I like it the way I have it now. Honestly, I like it the way I have it now. What I can do is, instead of this big header, well, I guess I could keep the header, but let's put these into helper functions, because then at least it becomes possible for us to, so we'll call this update nets. So we'll put this in functions, and that'll help us if we ever want to do a turbo simulation one day. So grab this. I still have that Kinoko Teikoku song stuck in my head. It's a good song though, I don't mind. Sometimes you get songs stuck in your head that are not good. Now this draw stuff, we can just leave it right in here. Not really a big deal. Then this update state. Oh, actually, I really like this sentinel element. I kind of did it as like, I thought it was going to be a hack, but it has worked out really well. So update state. Okay, so now we go in here, update state. So this should now behave the same as it used to. Yeah, I really like the instant change there when you're drawing stuff. This really is the way to do it. So yeah, so now if we wanted a turbo speed simulation, I mean, it's very simple. We would just do function what do I call it? I'll call it one simtick, I guess. Function simtick. And it's quite simply update drivers, oh no, update nets, update state. That's all there is to it. So, yeah. Now, we can, so you know what? This is actually part of drawing, isn't it? I don't need dump nets at the moment. Okay. Now, let's go back to what we were originally doing. Function B. Menu item. B and 1 LRX left. Okay, so L is the LSB, then it goes R, then it goes X. Speed. Speed. Let's just make this a separate function. Function set speed. So actually, if we do this carefully, we can actually even just do this. set speed of 0. And now we will do speed vals and speed index equals 1. So I guess we don't need sim speed. Well, we'll make it a local. Oops. Local sim speed equals speed vals of speed index, bam, bam. So what speeds do we want to have? Well, obviously we need 0. This is for single step mode. One. All other numbers is frames per tick, frames per sim tick, I'll call it 1, 2, 5. Let's do it like this. So 2, 5, 10, 20, 50, 100, 200, 500. What else? I mean, is this enough values? 1,000. Sure. No, actually, I do want this. So actually, we will do this. And local speedster equals sim speed equals 0 and single or of sim speed, like so, and speedster. Set speed like that. Now what we will do is if b and 1, then reduce speed. Actually, we need to have this at the top. Speed index equals max of 0, speed index minus 1. These long variable names are a real pain in the butt. That helps a little. Actually, it helps a lot. else if b and 2, then increase speed. So we will do this, but like this, instead of 0, it'll be num speed vals. Okay, now let's just check that our function even works. Speed nil. Uh-oh. 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 Speed 0. So the speed index starts at 1. I guess I should conjugate this properly. Not conjugate. Oh no, yes, conjugate. Yeah. Anyway, it's probably some stupid thing about, you know, b and 1. Okay. We need a log statement of why we're getting nil. Log index. We better do this because I think we have some nils coming in somewhere. Speed. Let's start with this. Index 0. Why is the index 0? Oh, that's why. If, oh yeah, this is another Lua thing. 0 evaluates 2. True. If b and 1 is not equal to 0. Oh, greater than 0. That's actually a nice way to do it. I noticed that here. Okay. Great. No. Keep hitting the wrong buttons. When you're running a cartridge, you hit escape to open the pause. Wait, no, you don't. You hit escape to go back to the console. Anyway, go in here. Speed single. That's not right. Nil. That's really not right. Single. Okay. We've got some issues. No, I don't want this screenshot. Okay. So actually the default here is 2. And oh, this should be +1. Okay. 2, 5, 10, 20. Yeah, there we go. Single. Oh, you can't hold it. Lots of log messages. Okay. I kind of think we need a couple more small values. Whatever. Let's actually just see what this is like before we... So now here is the trick. We need a frame number. How do you get the frame number? I think that's just the time function. Returns number of seconds. I mean, so I know that I could set up a counter variable myself in the update function, but I think there's a function for this. Returns number of seconds elapsed. Parameter string. Tick split. No, this is music. Well, actually, why don't I just search this for frames? Oh, wait. This is fascinating. I could have done my... So this logic, this ugly logic I have here to manually, this button DD stuff, I could have done that like this. Should we just try that? Maybe we should try that. What did I just do? Set button push delay and speed. And then we can just use button P for everything. Poke 0x 5f 5c. Set the initial delay before repeating. I think I'm using 2 frames for this. Poke 0x 5f 5c 1. Maybe I'm using 3 for this. Now, let's go in here, and instead of this, let's do local val equals button P and see what that does. That's weird. Oh, whoops. 5D. Okay, I think this needs to be a 2, and then I think it'll be exactly the same as what I had before. Almost. I think maybe the 3 is correct. And what did this feel like before? What? What's going on? How come this is broken now? What? So it's easy to move one by one. It doesn't really feel like there's a huge delay before it starts repeating. I find this really nice. The other one felt like it had a longer delay. So you can move it once easily. I think it was just my imagination. I think this is fine. So we'll keep it, but I see why. The button DD stuff. So button, That's strange though. What am I using? Okay. I'm using button P for, that's why that was happening. Yeah. But now that we have it working this way, we can just straight up get rid of that. And then when I want to do my, well, actually no, I was only using, oh shoot. Because sometimes I only want to hit a button. Okay, let's not delete it yet. It was, you know the old maxim, don't fix what ain't broke. I mean, to a certain extent, it was broke because it was ugly and taking up a lot of visual space and just cluttering the logic, but we'll leave it the way it is for now, at least while I'm still debugging it. Okay, now, what was I doing? Oh yeah, right, the sim speed stuff. So it's pretty simple actually. I need I'll call it countdown, and I'll set it to 0. Now, no, let's not do that. Let's just call it fnum. So there's going to be a really annoying case where it wraps around. So we can work around that though. Equals 0. And then here in the update function, what we will do is fnum equals fnum mod speed plus 1. Do you get an error if you do mod 0? No, you just get the same number back. So if sim speed does not equal 0, then and anything mod 1 should come out as 0. Yeah, good. Good. So the rule is if fnum equals 1, we do the state update. And we'll just update the nits on every frame. It's really not expensive. If fnum equals 1. Actually, we can do something a little bit tricky. Equals. Let's do button push. I'm out of buttons. Okay, can we do, yeah, let's do this. And 0x 3f greater than 0. And what we will do is, when we're in single step mode, we will just change the tool so we won't draw the cursor. Modester. If fnum greater than 0. You know what, we'll do if sim speed greater than 0. So right underneath here I'll explain if in single mode don't draw editing UI. I need to try and organize this a little bit. And UI. And actually, I may as well put this. I was just checking to see if, I think I said this in another stream, but at one point somebody had sent me a message, and because I didn't have my browser visible on my screen. I've only got one monitor, so I just never answered it. Oops. So now once in a while I check it. Anyway, if in single mode, don't draw editing UI. Or let's write this as the logic is written. Draw editing UI if not in single step mode. Draw grid, map, camera, if G menu, and speed greater than 0. Whatever. Well, I think it's fine. I think it's fine. Equals, now here we will do sim speed equals 0 and single for that. Oh boy. Fine. Okay. Ugh. Right. Everything works as normal so far. Set up our oscillator. Now, if I go in here and I set the speed to single. Oh my God. Okay, we got problems. We have got problems. So, function update. Equals, okay. Greater than, well, no, I can just depend on and 1 or 0. Now, is there anything else in update? Yeah, we'll just put in that update debug and return. Update debug, return. Okay. So, I got flashing lights warning. It's a little late there, but. Hey, cool. Look at that. Okay. Yeah. Okay. That's working. Cool. So if we put it in single mode, hey, check that out. We did it. Ah, okay. Now we have motivation to fix button P, because now it's using the default button P. But maybe that's okay, actually. You know what? I think this is fine. I think it's fine as is. Great. So we did that. We can check it off the list. But it would be nice to be able to scroll while in single mode, wouldn't it? Okay. So let's not do this. If you go into single mode, it'll just close the gate menu. And we will also do wait a minute. If button X, if mode equals 1, place wire. If mode equals 2, and we just pushed a button, okay, great. Actually, we don't need to change the mode. We can just set G menu to false. Wow, boy, am I ever good, huh? And then otherwise we erase. Yeah. Okay. Button pushed. So really we just want the movement. Maybe we should draw the cursor. Maybe we should draw the cursor after all. If sim speed equals 0, return. Actually, quit early if in single mode. But of course we need to update debug. Although it would be nice let's just move this like arbitrarily like up here. Okay, so now if we're in single mode, now what happens? Oh. So that's flashing pretty fast. Now we go in here. No, not in there. We go in here, speed 2, that's a little slower. Speed 5, slower. Whoa. What's going on? This is not right. What? Why are all my nets changing? What? I think... Ah, we have setup time problems, maybe. Interesting. Yeah. Through some... No, actually, wait a second. Yeah, this is setup time stuff, I think, or hold time, or one of them. Okay, 1 second. So, oh, yeah. It would be nice if, well, okay, what we can do, I mean, it's cheesy, but we can set the speed to some enormous value. Then connect these and quickly put it in single mode. So we should probably draw the cursor, but yeah, so now if I hit, so that changes. How fascinating. So now these both change. They get into sync. Whoa. 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 Okay, I'm a big fan of this single mode. Well, I'm not a huge fan of it. There's still a bit of, it's a little unwieldy. But what I'm a fan of is actually having it. Yeah. So they get into sync. That is hard to understand. Because the input to this gate and the input to that gate are the same. So then why do these two get into sync? So the minute we wire this up, that first gate is going to go to 1, so its output will change. Now the second gate is going to go to 0 and its output will change to 1. Oh, I get it. I get it. Wait, do I get it? Yeah, I do. This is like a pipeline. It's like a pipeline, you know what I mean? whatever pattern we see on the left-hand side will be repeated on the output of the circuit. Oh yeah, I need to draw the cursor. On the output of the circuit, just delayed by some number of cycles, and possibly negated if I have an odd number of negators here, but I think I have an even number. Okay, yeah, I understand why. Yeah, of course. This is like a shift register, but every other bit is inverted. But the value that we're shifting through is a pattern of ones and zeros, such that if you invert every other bit, it appears, if you freeze it in time and look at it, that all the bits are the same. Very fascinating. Very fascinating. I'm really starting to, get excited about releasing this one day. I think there's a surprising amount of depth that's just popped out. Yeah, all right, I need to draw the cursor. So we'll draw the cursor unconditionally, but there is no need to draw any of this stuff. We can just slot it in here actually, and de-indent all this. Get rid of this extra end. Draw a helper step to hint which way wire will connect, except when single stepping. Except during single step. Okay, one thing I haven't tested yet. Whoops. Oh my goodness. One thing I haven't tested yet is, let's say we're in the gate menu. We do this, and then, oops, I didn't do that. And then we go into single step mode. Cursor's still there, we can move around. Nothing happens, I don't think, if I press ZMX. Well, it's stepping the simulation, but I don't have anything visible. So now if I come back, we're still in component mode, and we can do this. Okay, great. That's a result. That is a result. So let's just go right ahead and push this to GitLab. I'm not going to bother changing the, well, maybe I will. The reason being, partly because if you're not familiar with Git, you'll see how I'm using it, and maybe something will be useful. But also because you'll see the commit message, and when you look, it's a public repo. It's here. This gitlab.com/mako. That's my username. And pico8.git. Anyway, so let's just see what's going on here. So we have this extra logic for updating. Minty seems to be struggling with the Unicode characters there. Compute gates for all net, so we draw them correctly. I moved that, yeah, so some little bit of housekeeping. Yeah, okay. Git add -u, and then commit. Add sim speed control, slight tidying. Yeah, so we do have an option for turbo speed. It's possible, but right now there's no need for it. What is next? let's just do the register elements next. So this is a case where I have to overcome my inertia. It's like there's a steep barrier when you first start a new task like this, because there's a lot of uncertainty, and you're just like, oh, I don't know how to do it, it's going to break everything. But that's actually the number one reason I'm using Git. I mean, I guess the number two reason I'm using Git is because it's a nice way to share the code with other people, but the number one reason is because it helps me overcome my inertia when I need to make a change in my code. Because now I'm not afraid of breaking everything irrecoverably. Like if I break everything, I can just like wipe all the changes and try again. So yeah, let's do it. The first thing we'll do is draw what we need. Yeah. So these are the 1 cycle delays. These are the 2 cycle delays, and I guess we'll have 3 cycle delays, and then that'll be it. And then for each of them, we'll have the version where the latch is asserted, and so they won't tick forward. Yeah, so let's just go ahead, put that there, do this. Is this gray going to show up nicely on our background color? Kind of doesn't. We got to do some more soul searching. I was checking. I think I mentioned that I was watching back the other streams. I mean, not every single second of them, but just like kind of browsing through. And I noticed like I spent so much time settling on this design for the gates. I'm glad I did though. The whole time I was like, I shouldn't be fussing over something so minor. But no, now that I'm on the other end of it, I'm really glad that I spent so long and tried so many things to come up to this design. I really like it. Yeah, I really like it. I think it works really good. Anyway, back to this problem. We need something that looks good against this color. And keeping in mind that the screen background may sometimes turn pink if we hit a post condition. So, and keeping in mind also that the cursor is blue. And it looks too garish anyway if I do that. No. Maybe, actually. How does this look if I do this? No. The gray was a nice color, but the gray doesn't look good against our beige background. And I've gotten used to the beige background. In the earlier streams, I noticed I still hadn't settled on beige. I had the background white, and it just looks weird to me now. I'm used to the beige. I think it's here to stay. So we can try the secret alternate palette. I'm really gonna struggle to remember how that works. I think if you set the upper bit of the byte, it uses the alternate palette. Let's try that. P alt, oh boy. Oh goodness. All right, hold on. Let me grab the doc window again. How do you do this? P alt. Set. Oh no, I need PAL, not P alt. I always get confused. This is not P for palette, alt alternate. It's PAL for palette, T for transparency, but it always confuses me. When the first parameter of PAL is a table, colors are assigned for each entry. For example, to remap color 12 to 14 to red, or to recolor the whole screen shades of gray. Whoa, that's cool. That's actually really cool. That's super cool. Okay, anyway, what we're going to do is for I equals 1 to 15, do pal of I negative I and so now let's try CLS1. That looks exactly the same. This all looks exactly the same. All right, I give in. Let's open up the. Okay. I guess I should explain these recent searches that make me seem like a crazy person. But okay, this one is from this morning. I woke up and I was freezing my butt off, and I checked the thermostat and it says 22, and I was like, why am I so cold? This was actually interesting. It's because there's like they claim, I don't know if it's true, there's a psychological effect where the lower light of winter makes you feel colder, not to mention that the surfaces you're in contact with will in general be colder and it's more drafty. And let's not forget also that hot air rises, so even if I've got the heat turned on, and even if it is actually true that it is a pleasant 22 degrees at the level of the thermostat, it may be a less pleasant, I don't know, 15 degrees, I'm just making up numbers here, at the level of my feet. And actually, to that effect, I stuck my thermometer on the floor earlier. Let's go see what it says. It's virtually identical to what the thermometer was reading when I had it on my kitchen counter. The thermometer, so the thermostat is one thermometer, and this other thermometer is just a cheapo one I bought from the Canadian Tire that also shows the humidity, because I was trying to understand what was going on with the humidity. But I have no idea how accurate this is. It's really cheap. Okay, now, this bright white flashes 311 questions and answers line. I think I mentioned this on an earlier stream. Every once in a while, I'll notice like these just bright, they look like electrical arcs, just these really bright flashes. And normally I always see it from the exact same apartment, like a block away. But this time I actually saw the same phenomenon with that little red light, like the little orange light. It's like a little orange light and then once in a while a bright flash, which made me think it might have been like a camera, because you know how when you are pressing down the shutter, it'll, before it flashes the big flash, it'll flash a small like orange light. But I don't think it could have been that, by the way, because the orange light was actually kind of constant and moving around separate from the bright white flashes. So, and I saw this exact same phenomenon in another apartment, even closer to me, and it was freaking me out, and it was late at night, and I was getting like weirded out. So I was like, who the heck can I ask about this? So I tried searching it. It was just a bunch of people going like, oh, I got UFOs or whatever. And then I tried calling 311, but they were busy. And I thought maybe there's a general questions and answers line, and I couldn't find anything. And then I gave up and went to bed. And then here I woke up this morning. Is the knife story true? This was an autocorrect. Apparently, there's a story about Evel Knievel, about how he got his name. That his real name was something like, I don't know, William Knievel. But one night, so the story goes, according to his personal website, one night he was in jail, and there was another person in jail with him who his name was something like, I don't know, Robert Knofel. And he had gotten the nickname Awful Knoffel or something like that. And then Knievel, I think William Knievel was like, oh, well, if he's awful Knuffle, I must be evil Knievel. And I was like, there's no way that's true. So I was trying to search, is the Knoffel story true? But Google Google autocorrected it to knife, so now I just have and like I forget who Alison Burke was. I think someone mentioned her in a YouTube comment. And I was like, who is that? SR Latch, I think, was from. That's strange. This is an old search. Maybe I accidentally researched it or something. And then where did I plain ordinary clothes? I just need clothes. I was like, where do I get normal clothes? Because the place where I live right now, I'm surrounded by friggin' like haute couture, you know, clothes stores and stuff. I just want normal stuff. But I felt compelled to explain this because if I just went past it, people would have been like, who is this guy? Anyway, I promise it's all normal. I'm not like okay. Where was I? Pico 8. Yeah, let's figure out how this works here. Color 0, color 1. There's some secret colors. Oh my god, there's so many friggin' ads. Yeah, the secret. Yeah, for the secret palette. God. Screen palette system. Maybe I need to do this. Oh, there we go. Okay, now we're cooking with gas. Okay, what else do we got? That's kind of neat. I guess I could just see the colors over here. I need something that looks good against kind of a dark purple, garish red, and beige. Just get out of here. Okay, go. God, just get out of here. Ready to see warning fast flicking colors. Yeah, whatever. Now, let me. Okay. Now, so let's now do CLS 15 to get this color. No. Okay, well, I guess we could do this with MS Paint. I mean, why not? If we're going to the trouble. Grab the eyedropper. Oh, you can't click other windows with the eyedropper? That's fine. I can at least take a screenshot. Go into MS Paint. Use the eyedropper. So this color is 255. I gotta convert it to friggin' hex there. 255, 204, 170 in hex. All right. 204 in hex. Yeah, I figured these would be double letters. Because you know how in HTML, if you put in a hex code, you can just put 3 hex digits, and what it'll do is it will copy the nibble to both bytes of the color byte, or it'll copy the nibble to both nibbles of the color byte. And I had a feeling that Pico 8 would only be using you know, I'll bet you 170 is another one like that is too. Yeah, so we need FCA. Peach Crayola. Fascinating. Okay, and lock this. Now, I think the red in Pico 8 is just, no, not this. What is it? It's 8. Yeah, I think this is just like red. I think it's plain red, and we can check, but screenshot, MS Paint. Take our picker, edit, whoops, edit colors. Oh no, there's a little bit of blue. 77. 77 is 4D. Oh, fascinating. It's not all doubles. All right, so we got F77. Winters. That doesn't look right. Oh, no. 4D, right? Yeah, there we go. Red Crayola. Jeez, we got a lot of Crayola in here. Okay, now for the purple color. What is this? Purple Crayola. All right, print screen. Copy into MS Paint. Use the eyedropper. Edit colors. Convert to hex. Man, what a friggin' set of steps here. 70. $25. 53. 70, 25, 53. No, it's not purple Crayola, it's just pansy purple. Lock this and generate. Where's the generate button? Oh, they're not going to charge me, are they? Get out of here. Just, okay, fine, whatever. Where's the generate button? I mean, it's got the word generator on it. Check palette contrast. Oh my god. Fine. Oh no! All I needed to do was hit the space bar. Wow. Oh, okay, it saved my colors. Okay. Lock, space bar. These are a little bit kind of dark there. So we're getting a lot of blue. We're getting a lot of blues and greens here. Actually, black may not be bad. Well, it might be a little bad. Ooh, okay, what about this, like, minty color? We could try minty. Or even this, like, I don't even know, is that blue-gray? Let's see what we got here. This 131, it's a little dark there, but let's try to change it. What's a color I don't need? I'm not really using white for anything right now, so color 7. Let's trade 7 for this 131. and wow, this is strange. Okay, so oh no, that's too gunky. What else? We can try 134, maybe? Well, I won't say it's bad. I wouldn't say it's good. What if we try that 141? Well, or what if we try 133? Oh, no. What was I thinking? 136? Ugh. I think I may have chosen bad colors. Now I'm stuck. 135. Ugh, doesn't look good against the beige. What do we got for grays here? What haven't I tried yet? Well, I'm almost scared to try this, but no. Well, it's kind of an interesting little jet black color, but let's see what it looks like against the red, just for fun. Not literally jet black, by the way. No, like, I've been trying really hard to make like bright, kind of peppy colors. The gray is all right. I mean, it's a little bland, but it otherwise is, you know, inoffensive. These colors are all like dark and dingy. Let's try 139. Why not? Try the greens. Dun, 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 dun. Yeah, the green against the red is really jarring. Have I tried 131? I think I did. Is this a cursed problem? Is there no solution? Ugh, that is hideous. It's truly hideous. Oh, God. I think this is a cursed problem. Alright, what if we just try plain white? Well, it definitely looks good against the red and purple. It's a little low contrast against the beige, but I wouldn't say it's bad. Remember what the problem was with the gray again? This is even easier to see against the beige. Man, what was my problem with the beige? Or the beige, the gray, I mean. I think I thought it looked a little bad against the beige, but honestly, it kind of looks fine. Maybe. Alright, let's stick with the gray for now. Let's stick with the gray for now. Alright, let's keep drawing these guys. 3, 4, 5, 6, 7, 8. And now we need all of the states. Bam. 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 And bam. And then for all of these, we need the ones where the latch input is activated. So okay, X0, Y, 40. I guess the X doesn't matter here, but I need Y, 48. Wait, no, this is inclusive, so I need 47. Copy, stamp, put x0, y48. Good. They look a little strange when back to back. Maybe you know what? I'm not gonna get all weird about spending time editing sprites, because honestly, editing sprites has been a really valuable thing to do. Like, it has really helped the way this looks and feels. Now, I think it's fine that they plug right into each other like that over here, but when these edges are next to each other, it's a little kind of odd. So what if we do this? Okay, what do we think about that? I'll just do a few of them so I can get a picture. Okay. That is kind of cool. I want to see what it looks like on the threes. Whoops. Kind of feels like if we're doing this, we could make the taper more dramatic, like this. What do we think about that? Whoops. Yeah, actually, that's pretty good. In fact, we could even do this. Actually, I don't like that. I think I liked it better like this. So what do we think about that? Let's just edit some more here just to get a better idea. Oh, I just had an idea. Oh, yeah. I think this is good. Well, I say that. I think it's good to have the visual separation there, although it does kind of obscure the latch inputs. So what if we do this for the latch inputs?
I like the shape of this better than the shape of that, but I like how this has more like obvious latch inputs than this. Oh, wait, I have an idea. What if, because we're gonna change the color when it's latched, right? What if we, okay, hold on, let me just edit a few of these. I mean, this is kind of a lot of brute force here, but whatever. I used to be someone who would think like, oh no, it's never okay to do brute force. Like you always have to do it the right way. And I'd be super perfectionist, and you know what would happen? Like, okay, there is a way for me to do this programmatically. I could type in some commands into the Lua console of Pico 8 and edit my sprite sheet and do that, but I mean, oh whoops, oh I got more changes to make. I forgot about doing that. Yeah, I mean, I could do this in the script console. But that would not really save me any time. I would probably spend more time debugging what I did, and maybe even more time fixing stuff I accidentally broke and in the sprite sheet. And yeah, this honestly is the right way to do it here. So now, here's my idea. Let's go in here. Y40, good, and then Y47, good. X0, Y48, okay. Anyway, so now for these, we can change the color of this gray body to indicate that it is inactive. I can speak English. And let's think about what color shows that best. We could make it a darker gray, but that looks so bad. We could make it white. Although white may not look too good against the beige. We could make it a different shade of, oh no. Well, actually, let's just check it against the white, or the beige, I mean. That is not bad, but I think we can do better. I think maybe we could even like, you know what? What if we actually changed its shape? Oh. Oh no, but that will imply a negator, won't it? Because I'm already using green for negators. Um, hmm. Actually, that's not bad. Just like this. Yeah, I think I like that. I think I like that. Let's get a feel for how this looks. So maybe we have this guy here latching this, followed by just a plain delay element. I think this works. I think this works. Actually, though, one thing I don't like is how, if we're not plugging in a value, it's visible. So, oh, but if I don't, okay, what if we try this? Actually, this at the very least. I could do like this, which would make it a little easier. It's not immediately clear you can plug something in to latch it, but then again, it's not immediately clear with redstone repeaters either. Oh, actually, I really like how if you're not plugging anything into it, like if it's not latched, it just looks like a little thing. Actually, I think I like this. And what does that imply for the latched? Because for the latched, Actually, I think the latch might be okay. Because here, even if we only plug it in from the top, I think it makes sense to have this thing appear on the bottom. Oh, what time is it? Okay. I need to leave here at around 11. Just making sure that no one has tried to say something to me. Okay. All right, let's close all of this. Well, for the latched versions, I'm still a little unsure, but I definitely like the unlatched version. I think I'm keeping this as is. Yeah, I think I'm keeping this as is. Let's just quickly, there's a quick hack we can do here. Which is a little insane here, but it'll at least let us see what this looks like against the beige. Yeah, I think this is fine. I think it's fine. Okay, I think it's fine. Well, there's another quick hack to see what it looks like against the beige, which is to do that. Well, I guess it's not that quick, but you know. Anyway, let's save this. And now let's try coding it up. So we need to add it to the component menu. So we only need 3 things in that component menu. We really just need the group of 3, and let's take it for the base. So that is 86. So we need 80, 82, and 86. Oh, actually, here's an interesting thought. If we put it in the component menu with the latches on it, it'll imply that when you place it, you can connect something to the top and bottom. So I like that, actually. So 96, we need 96, 98, and 102. Where's Jordan? We've got Gord and Jordan. Now I need a cute name for this guy. Order for drawing registers. Reg. Reginald. Okay. Let's just quickly in def here. We will do alt equals blank and return raw get t default. Oh no. Nah, forget it. Honestly, I just realized, because we're using numerical indices, it's actually, I think it's actually fine to set this to def, even though it's an absolutely unforgivable hack. But it was already a hack, so I wonder if this actually, oh yeah, I haven't set reg yet. I know somebody named Reg. Anyway, so we can still place things as usual. Seems fine to me. Oops. Okay. So now, Reg, set meta table. Should we put them in row 6 or should we just tag them on row 5? We can put them in row 6, why not? So we need 96, 98, and 102. Over here, where am I doing that? Here we go. 6. Corner cases. Else if g cell y equals 6, then... I mean, this is all corner case city, but honestly, who cares? Okay, now let's go in here and in draw G menu, Gord or Jordan or Reg. And we also need this to go to 6, and this should probably be 61 and 60. Uh-oh. Oh, whoops. F. Ah, okay, we have run out of room. So this is fine up here. If CY is less than 8, TOY is equal to, that's why, like that. Okay. Huh, fascinating. Because place component, we'll just ignore that. Yeah, so now let's edit place component. I mean, this is insane now. There's probably a smoother way to do this, but honestly, who cares? So, I mean, I care, but, you know, place register CX CY. And R. Ooh. Now, I think, I'm just thinking about it. Is there a way we can not write another 100 lines of gibberish? Like, can we reuse this place gate function? Let's think about it. So instead of this gate tile offset and doing this, maybe what we'll do is we'll create this object to place inside place component and then call this function. Oh, wait, I have this written in, but I'm not doing it. Oh, I thought I. Hmm. Hmm. Anyway, let's do that. So instead of GT, we will do O is the component object. Well, now I have a function called place component. Place. I'll just call it port obj, I guess. Place port obj with an O, an O. No. O in the function, but G here. O. O. Yeah, so type gate, blah, blah, blah. Place port obj, do that. I mean, I think we can use that for the junctions too, couldn't we? Right? Because we erase the square, create the objects. We fill the ports. Ah, okay. The table we add into is different. And gates auto-connect, but junctions don't. T is table to put it in. Well, LST. What I'm angling to do here is put junctions, like make this all use the same thing. Now the other thing here, don't worry, I have considered this here. So if n dot port, then see that? Oh, but I have a different case for junctions. Ah, shoot. Ah, stupid. Ah, man. Fine. Fine. This is fine. This neighbor. Okay, yeah, so this is we're not gonna try and put junctions in here. It's just not gonna happen. But at the very least, we can use this in general for components. So if I add like input outputs or other things, we can reuse this. So at least that's a win, I suppose. Although I do need to change all of these. Sorry, I guess I was just sitting there quiet. I don't know for how long. I was thinking about how right now the gates have a delay. Oh, no, this is fine. Okay, this is cool actually. Well, I don't know if it's cool, but no, never mind. It's not cool. Well, no, it is cool. It's basically a clock to queue. So I was just thinking to myself that right now the gates, they have a delay because I don't copy the state of the gate to the state of the port. Because I was looking at this state here and I was like, oh yeah, I don't copy the state of the gate to the state of the port right away. And that's why the gates have a delay. And I was thinking, oh, well, for the registers, the state of the port should really be equal to the state of the the bit 0 of the state or whatever. And I was like, yeah, but then I realized something. We already have a gate that appears to be just a pass-through that is actually delay 1. Now it doesn't have a latch on it, but it is a delay 1, which means that our basic register is delay 2, and it's like we have delay 1, we have delay 2, although with delay 1 you can't latch it, so that's a little iffy. But anyway, No, I think it's fine. I think it's fine if we don't copy bit 0 of the state to the output port right away, because it'll be like a clock to Q delay, and everything's got delay. That's just the way this simulation works. That's the way I did it, and I think it makes things harder for sure, but I think I like it, and I think I'm going to keep it. Yeah. Okay, so now let's do place a register. And I guess we'll have a global table of regs. Is there any reason why we wouldn't do that? If we put it, so here's what I'm thinking. If we put it in the table of gates, the advantage is that in code where I'm erasing something or just generally modifying components, I don't need to check what kind of element it is to know what table to add it to or remove it from. The advantage to making it a separate table is that when I'm drawing, or like when I'm looping through these tables every frame to either draw them or to what's the other thing I loop through? I know there's something else. It's just not coming to me. Oh, right. I looped through them twice. One to simulate them, one to draw them. So it might be useful if they were in separate tables, because then it would just make the simulation loops a little cleaner. Okay, let's first see if we broke anything. We broke syntax somehow. Oh. So I won't try to place one of these because I know it won't work. It'll say function does not. Oh, because of the cursor. That's kind of funny. It'll say function does not exist. Yeah, see. That's okay though. Let's just see if everything else is still working. Oh. Attempt to call global place port obj. Is that not what I called it? Oh, I just called it place obj. Yeah, I like that better anyway. And actually, this will also be like this. So now if I try to place a register, it'll throw some error about a nil value or something. Or no, actually, this, I don't know. I don't know what'll happen, but I won't. I mean, we can try it. What's the worst that could happen? Oh, no, we got an error, whatever, right? So let's just place, uh-oh. I see. Maybe I don't see. C equals L. Oh yeah, L is nil in this function. So whatever. It's just we're recomputing this same value like a gazillion times, but we're not hurting for performance right now. Only when we start hurting for performance will I start going through and cleaning some of this up. Yeah, so now that should fix that at least. Okay. Actually, because I also want to check this out in the single step mode. Yeah, cool, huh? Okay, so we didn't break anything, good. Now we need to actually do this. So local O equals, and we need to create a global, well, that's right, I still have to decide, am I gonna have a global regis table or not? Let's not, for now. Let's not, for now, because we can add that later. Let me put it this way. The work needed to add that support in later is pretty much the same as it would take to add it now. On the other hand, doing it this dumb way is very little effort, so it's very low cost to just try this out and see where it leads us, rather than actually burning our brains and thinking about what is the best and what isn't. So local O equals, we need type, this is reg, coordinate equals L. What else do we need? I guess we'll take the reg type. Well, for now, I guess I will take tile or tno equals r. We'll save this for now. We'll do something with that later. State equals. Now, here's where we need to make a decision. Will the state be a value that will update with bitwise ops, or will it be a list? It should be a value, because we're going to use that value to look up the gate number. Yeah, I mean, I drew them in the tile table in order on purpose, because if the state is 1, we add 1 to the offset. If the state is like, so if this was our base tile, right, and our state was 5, we would add 5. That's exactly what it should be. So yeah, we will make it a value. So yeah, and the state will start out as 0, as it should. What else? Oh yeah, we need to make an empty. Okay, well, you know what? I mean, we could just do that in the function. Okay. And what else do we need? So we've got the type, the location, the base tile. This is specific to computing the gate's next state. But we could use a lookup table. we could use the exact same lookup table. Yeah, I think a lookup table is the right approach here, right? Because even for the 3 element registers, or the depth 3 registers, we've got 8. So we've got 3, 4, 5. We have 5 bits in the lookup. I mean, that's just 32 entries. We've got tons of space. Yeah, so let's use the lookup table for that. I'll write another script to generate it. So let's do the same thing there. We can call it the same thing. Love base equals we will put the state as the bottom 3 bits. So, okay, what did I call it in here? I called it T off. Yeah, let's use T off. And the lookup value base will be, I gotta think about this. So for the gates, I take all the ports, use those as the LSBs. So then I can take the state as the next couple bits. Oh, and the type, right? So the gate type figures into the equation. Oh, that's fascinating. Yeah, our type is just how many elements we have. That's cool. So there'll be a couple of useless entries, but that's okay. Yeah, okay. So what do we need? Local let is equal to, so map tile number to, I guess I'll call this delay length. So this 96 is 1. Is 2, 104. Oh no, 102. What time is it? Okay, I gotta leave in 2 hours. Think I can finish this in 2 hours? That might be tough. That might be tough. So now the lookup value base is going to be some calculation based on that. It will be let of r, let's put an assert statement. Let of r minus 1 times something times the number of entries per type, which is going to be 32 maybe. Because we have 3 bits of state. Now, even if we have delay 1, we're still going to treat it as if it has 3 bits of state, except the top 2 bits of the state are always 0, because who cares? So 3 bits of state, and then 3 input ports. Just for simplicity, like I'm not gonna, for simplicity, I'm not gonna bother to OR the 2 ports together You know, so 64 2 to the power 6. I mean, that's kind of a lot, but who cares, right? Yeah, who cares? Who cares? Now, let's go ahead and write this script that we need. I gotta fix my OBS here to show you the right thing. Okay. And then look at value base. I think that's everything, right? Type, coordinate, tile offset, look at value base, state. Yeah. Okay, that should do the trick for that. And I guess I'm not using this. And let's go and write that script. So we can start by copying gen gatelet to now gen reglet. Oh, the negators. Yeah. Well, we don't need that, so let's just get rid of it. We can keep that extract function. We can keep the main loop. And so now we have 3 times 64 entries to put in this table. And so local, yeah, the ports are fine. We'll leave the ports as they are. Now we will call this state equals extract I of 3 and just 3 actually. And we don't need that. Wait, why did I think we needed 64? No, because we have 6 bits, right? 0, 1, 2, and then 3, 4, 5. Ah, right, and we need the type. Okay, that's why it's bigger, yeah. Global type equals, oh, we don't want that. Type equals, or I'll call it length, dlength equals extract I of bit 6 and 7. Now, we will do local latch equals P2. This is a little trick I've seen before. Well, normally I would write this as does not equal. It's just a quick and dirty way of doing an OR of numeric types when you're worried about, now, what am I doing? What am I doing? I can just use, excuse me, I can just use the AND operator. This is Lua 5.4, so whatever. So P2 and P4 is not equal to 0. What's the operator precedence in Lua? I just don't know what it is, which is why I always end up putting brackets. Operator precedence. The lowest priority is the ORs and is OR and then right after that we have the comparisons. So yeah, actually it's what you would expect. So we don't need the brackets. I mean, I may as well keep them since I already wrote them, but anyway, now we know. Local latch equals that. if latch, then okay, let's do this. Let's do it like this. Local val equals state and 1. Oh, but we need the next state. We need the next state, not the, yeah, it's just state. Yeah, we output the next state from this table. Yeah. Okay. If not latch, then val equals val right shifted by 1 plus P3. Let's check that precedence table again. The shift operators are lower than the arithmetic, so yeah, this is fine. I think in C there's a weird quirk where the arithmetic is lower than the shift, or there's something to do with like bitwise ops that doesn't do the right thing in conditional expressions. It's a common error. The Deep Sea Secrets book explains why. It was because in the original language there was no difference between bitwise and, or like in a really early prototype, there was no difference between bitwise ops and logical ops, and they needed to support some old behavior and they just got stuck with it or something. I don't remember. Anyway, so now we need left shifted by the dlen plus 1, I think. Oh no, actually we can do it like this. We can put the plus 1 up here, that makes more sense. Plus 1. Okay, and then just for our sanity here, the 16 made sense. Does it make sense here? Not really. But we'll keep it anyway. The 16 is actually more driven by the size of the screen in the Pico 8 than it is by trying to make a human readable table. So the dealing is we take bit 6 and 7, add 1. The state is that. Then we right shift it and shift in the new value. Yeah? I think that works. Okay, well we should not have values greater than 8, so I think I did something wrong. Maybe this dlen is wrong. Oh yeah, actually we don't need to do this plus 1 because the P3 is already, it's already in bit 1, or bit 0 I should say. It's already in bit 0, so if the D length is 1, then you see what I mean? Yeah, this makes sense. Did I not save it? So the state is a 3-bit value. It's definitely bounded between 0 and 7. If we right shifted by 1. So what if the D length, oh, -1. Well, that's just one problem. using 6 bits. We need some debugging. Now, actually, this is something I haven't done very much in Lua. Oh, geez, I actually don't remember. I haven't done this really. I've only tried it once, like briefly, but this is actually something worth knowing. I mean, there's no debug in Pico 8, but there is in regular Lua, and I think it's worth knowing. So let's go ahead and do, where is it? Ah, here it is. So debug.setHook. I mean, I don't need to do this, but I kind of want to use this opportunity to learn how to use debug setHook. Sets the given function as the debug hook. The string mask and the number count describe when the hook will be called. The string mask may have any combination of the following characters with the given meaning. C, the hook is called every time the hook calls a function. R, every time it returns. L, every time it enters a new line of code. So let's do that. So function hook. When the hook is called, its first parameter is a string describing the event that triggered its call. For line events, the hook also gets the new line number as its second parameter. So type and line. I think that's actually new to 5.4. I think earlier versions of Lua didn't give you the line number. For line events, the hook also is inside hook. You can call getInfo with level 2 to get more information about the running function. Level 0 is the getInfo function. Level 1 is the hook function. Fascinating. GetInfo. Turns the table with information about a function. You can give the function directly, or you can give a number as the value of f, which means the function run at level f of the stack. Oh, yeah, tail calls are done properly. Interesting. If f is fail, the return table can contain all the fields returned by the getInfo with the string what describing which fields to fill in. The default for what is to get all information except the table of valid lines. If present the option f adds a field named func with the function itself. If present the option l adds a field named active lines with the table of valid lines. Not really sure what the table of valid lines is, but for instance, the expression debug blah returns a name for the current function. If a reasonable name can be found, the expression blah returns a table with all the information about the print function. Get local. This function returns the name and value of the local variable with index local of the function at level f of the stack. This function accesses not only explicit local variables, but also parameters and temporary values. The first parameter, or local variable, has index 1. And so on. Variables starting with open parenthesis, whereas in variables with no known names. This is not like, I mean, how do you get the index of a local? You know? Oh, the name and the value. I see. Whatever, man. Let's just line equals I don't know 24. Then debug.debug. Now, how do you do this? Print. Does this work? Don't really know where we got that open bracket from. Yeah, I pressed the up and down arrow keys and Minty, well not Minty, it's more, because Vim is running this in a special mode, Vim mode, whatever. So what happens if I print P2? Nil, yeah, that figures in pairs. Debug.getInfo to do print KV and well, this is not that helpful. I have to admit, you know, this is no GDB here. Maybe if I knew how to use it, it would be a little easier. Like, yeah, forget this. Oh, geez, I'm gonna have to do this like 100 times to get out of it. I can't Control C or else it'll close my Vim. I'm just holding the Enter key right now. I'm sure it'll end soon. Maybe I need to do this. Okay, this is just dumb. STTY saying, oh no, oh my goodness. Not responding. You can't see that in OBS for some reason. Yikes. Wait, actually, wait. Maybe I can just kill Vim inside the process, or the task manager, I mean. Ooh, except Vim is not in here. Oh, there it is. Vim. Killed. Lua.exe. I hope this doesn't screw up Pico 8. I don't think it will. Ah, there we go. Okay, STTY saying that guy. Vim and Regulate. Let's try this again. Recover. Yes, delete the swap file. I don't really understand the Vim file recovery, but I just hate. So rm star.swap. I don't see any swap files. Okay, yeah, let's not do this debug. Let's just do a plain old printf debugging, which is what I would normally do. Oh, print dlen equals dlen. Please and thanks. Wait, what? Oh, how did that happen? Dlen equals 2, dlen equals 2, dlen equals 2, as it should be. Dlen equals 1, dlen equals 0. And 7 right shifted by 1 is 3, 1 left shifted by 1 is 2. Adding those together. Okay. just a cotton picking second here. Print state equals state. Print latch equals latch. Just like whatever, just for the sake of debugging here. dlen equals 2, state equals 7, latch equals false. So 7 right shifted by 1 is 3. 1 left shifted by 2 is 8. Oh. Eight plus 3 is not 12 though. Wait. I did not think this would cause me this much confusion. But left shifted by 2 is right. Oh no, what am I talking about? 1 left shifted by 2 is 4. Duh. So P3 would have been 1. 1 left shifted by 2 is 4. Val equals state. State was 7. Okay. Do I have RL wrap? Damn. No, it doesn't matter. Oh, geez. I think. Oh, there we go. Okay. So state. Let's start with val equals 7. dlen equals 2. P3 equals 1. Now, what is val right shifted by 1? 3. What is 1 left shifted, or no, what is P3 left shifted by dlen? 4. Val right shifted by 1 plus P3 left shifted by dlen. 4. Excuse me. Val right shifted by 1. Val right shifted by 1 plus P3 is 1. Wait a minute. This is a precedence thing? I checked the precedence. Oh, what? This always gets me. I thought... Okay, well, now I know why. This plus has higher precedence than the shift, which is ridiculous. I don't think anybody expects that. And C has the same thing. So, yeah, let's get out of here. Now we can fix this. Delete it. Get rid of that swap file. And let's put in some brackets. Ah, I see. Well, no, still, I don't think anybody expects plus to have higher precedence than the shift operators. I don't think anybody expects that. Whoops. I don't need this anymore. I think this will fix it. There. That seems to be a little more like it, so. 16 times 4. I think this might be wrong up here. Let's consider index 10. So if I is 10, then dlen is 0, state is 1, P3 is 1, and then P2 and P4 are 0. So we've got 1, 1, 0. This is 0. So the val starts out as 1. We right shifted by 1 to get 0, plus 1 left shifted by 0 should be 1. Right? 1 right shifted by 1. By 1 plus 1 left shifted by 0. Syntax error. What did I do? Fine. God. 1. I don't understand. Oh, wait, no. The type is in the upper bits. So why are we getting a 2 here? Why do I have so many bugs in this? I like the gate let took me like no time at all. This is, for whatever reason, not working well. I was hoping that maybe somebody was typing in the chat to be like, "Hey, idiot, you need to fix that thing," but I understand. If the D length is 0, I mean, maybe it's correct. No, it can't be. I don't see the problem. Why are we getting 2? If I is 10... Oh, wait, no, I can't count. I can't count. Wait, hold on. Let's run that again. This is not 10. This is 16. So this is 0, 15, 16, 17, 18. So... yeah, we've got 0, 1, 0, which means P3 is 1, and the state here is 2. Ah, I see. This is a situation that could never possibly happen. The state being 2. I get it. Because if you start in state 0 or 1, the only state you can ever go to is 0 or 1. So you would never leave that line. On the other end here, there are some cases where you can go to state 2, which lets you go to, which means, okay, we're allowed to go to state 3. And given that so this is the stuff, wait. We have 8 entries per state. 1, 2, 3, 4, 5, 6, 7, 8. So that means we're allowed to go up to state 2. From here we can go to 1 or 3. Yeah, and that's right. We can't escape state 3. We can't go to state 4. And then over here we can go to 0 or 4. Yeah, okay, okay, this looks right now. This looks right. So finally we can put this in. Where's my gate LUT? Should be big on obvious. Gate LUT. Reg LUT. Gate value lookup table. Select format is. Oh yeah, I better write this in. Reg value lookup table. Select format is delay len 1 down to 0. State 2 down to 0. And then P4, P3, P2. Okay. Now, for the simulation, it's pretty simple. Oh yeah, I moved it to a function, which is pretty nice actually. It's down here somewhere. Update state. For convenience, okay, so here what we do is pretty tricky. We will do local LUT equals, I guess I'll say gate LUT if g.type equals reg, then we'll do LUT equals reg LUT. Wait, why even bother doing this? Why even bother doing that? Why not just do this? Lookup value base equals that. Lookup table is equal to reg LUT. And same thing here. Lookup value base equals that, and then lookup table equals gate LUT. So tno to len. I think that's just a little bit cleaner. Yeah. Reg LUT, gate LUT. I think this is the only place we create gates, I hope. Now we can go in here, back in, in here, back to our simulation, and instead of gate LUT, we will do g.lut of lookup value. So lookup value is lookup value base, and lookup value equals all that. If g.type equals reg, then lookup value plus equals g.state times 8. Yeah. Okay, so that should take care of simulating it. That should be done. Now we need to draw it. So draw a grid. If it's a net, check neighbors to determine tile to draw. And not port. Okay, we're getting there. Try to fix this ugly neighbor net thing. So that takes care of net. Else if gate. Else if junction. Else if o.type equals reg. then local latched equals O dot port 2 dot neighbor dot state or O dot port 4 dot neighbor dot state local Tino equals O dot T off plus latched times 16 plus O dot state. And then our classic M set, which I'm now realizing is in every single branch, which means we can factor it out, but whatever, let's not worry with that about that yet. So now we can draw them, we can place them, we can simulate them, but now the most difficult thing of all, can we connect to them and maintain all our invariants? Oh boy. So if type decay it, he is gate neighbor. If blah, if P is net neighbor, merge previous incur, else if C dot type equals gate, if P is net neighbor. I think here, do we need a special case for junctions? Yeah, so just, I mean, I always, yeah, C dot type equals reg, wire on gate or reg. Okay. I think we can do the same thing for this too. Can we combine this with junction? Probably not. I think I should just stop trying. Yeah, I should just stop trying to combine the junction case with the other cases. I mean, every time I tried to do it, it didn't work. The junctions are just too much their own stupid thing. So yeah. Now the last thing I need to know, I think I need to do this. I haven't thought about it yet. Let me go see how this variable gets used in a second. Yeah, I think that should work. I haven't thought about it very deeply. I'm a little sketched out by it, but Okay, no immediate errors. Let's try things that used to work. Okay. Okay. Let's try placing a, yikes, assertion failure. Oh, because I renamed it. Okay, let's try placing gate or reg. Attempt to index O. A number value. Okay. Oh, okay, because I never changed this to say R. Oh my god, okay. Slow down, slow down. Single step. Something is... Okay, something has gone very, very wrong here. Oh my god. No bad post conditions, which is odd. We need some debug statements. We need some debug statements here to see what in blazes is going on. So good thing I kept these. Oh, actually, no, I called it tee off in the end. Lookup value is 128, huh? Lookup value base equals t node to len minus 1 times 64. I just read this in my head as reglut. What time is it? Okay, I still have over an hour. I think I can fix this before I have to go. I think I can. Debug state equals, please and thanks. So the state is just going haywire. Why is the lookup value 128? Oh wait, no, that's fine. 128, of course it's fine. Of course, because we need to be in this section of the table. The lookup value is fine. What I'm wondering, yeah, okay, so this actually needs to come here for me to even see it. And, whoops. And Stop. I got lucky. State equals 0. Which means the lookup value is 128. I think I need to do a +1 there because tables in Lua are 1 indexed. Yeah. Yeah. So that might be it. That might be the whole problem. Yeah, there we go. Although, yes. This T off needs to be R minus 16. Okay, great. So far so good, no post conditions. That's a good sign, I suppose. Put a bunch of these in a row. Let's put on one of these. Whoa. Whoa. What happened there? What? What? There's no nets. What? Is the blank state going to 1? That can't be. That can't be. Let's just quickly try. Debug. Draw. Well, let's just give this like, I don't know, a nice little icon so I can find it. I'll just say P2 end state equals. What? P2S. I think what's going on here is that this gate plugs into the blank state and it's setting the blank state to 1. I think that's what's happening here. So this is kind of I thought I was already doing this. Weird hack that I shouldn't need to do, but I do. Well, I shouldn't say I really should say we. That we shouldn't need. Reset blank state to 0. Yeah. All right, let's try it out. Let's put a bunch of these in. Are they even connected to each other? Who knows? I think they are. Okay, I mean, you know. Are you ready? Wait, let's make it even more dramatic. Let's make this even more dramatic. Okay, put it on single. All right, moment of truth. Let's press X. Oh, yes. Okay, now does it? Oh, well. was going well for a while. Attempts to perform arithmetic on field state, a nil value. It threw an error here, so I think maybe O dot state is nil, which I think hints it might be something wrong with how I'm using this lookup table. I can't think of anything to do other than to just debug it, so O.state. Well, no, actually, that's being printed right now in the sim messages, so we'll single step it again there. Okay, so far so good. Let's check the stuff. We got one net, 7 components, is that right? Yeah, 7 components. Where's my stuff here? Wait, where's all my printouts? From the lookup values and stuff. Did I disable those? I don't remember disabling those. Oh, because I'm in single mode. I see. I guess I'm just gonna have to think about it. Just gonna have to think about it. Or here's something we can do. We can. Okay. I have an idea. What I can do is put this in frame by frame mode. Put it on speed single. Oh wait, no, that won't work. Well, you can just put it on speed 1 in frame by frame mode. Oh, I forgot to put it in frame by frame mode first. So it seems like we only need 3 of these to make the thing happen. Okay, put it down to speed. Oh wait, before we do that. Oh wait, I've run into a problem. I can't set the speed when I'm in frame by frame mode. Maybe I can. Okay, hold on, let's put this back. Let's do this. Go in frame by frame mode. Open up the pause menu. Will this work? Well, we can just call set speed, I think. Hey. Except it didn't work. Oh, yeah, left. I need to set it. I need to do set speed of 2. Hey. Okay, so now it should be. Oh, but now I can't open the debug menu. Shoot. Man, I thought I was being clever. So at this point, for some unknown reason, the state goes to nil? But how come it goes to nil on this one? What? Okay, let's try our other approach there. So we have a problem here, right? So let's comment this out. Or, well, actually, let's just comment this out, make it 0 for now. And we will debug. No. Log? No. No, it'll log on every frame. So we need debug. O.state equals. I really don't know how helpful this will be. Let's just get rid of this. I don't really need it right now. Oops. O.state equals 0. All 0. Oh. Wait. Update state. Who actually sets the state of port 1? Who does that? Is that up here? If g dot state is greater than 0. Oh no, if g dot state and 1 is greater than 0. There we go. That actually should fix that. How was this working before? Because I had if g dot state equals 1, set your neighbor to 1. So then how was that working? How is it working with just 2 of them? Do drive gate 1, g dot state equals 0, drive gate 2, g dot state equals 0. So g dot state equals 4. What's going on? What is going on? What, I'm getting different results now. How was this working before? Wait, why did this suddenly stop working? Well, actually, hold on. Let's save this. Or copy it, I mean, because I'm about to undo. What? What? What else can I undo? I mean, that's just editing debug statements. Whoa, whoa, whoa. That's what it should be. I don't understand how it was even getting that other behavior. No nets, 4 components. Wait, why is this broken now? Oh, of course, of course, of course, of course, of course. Because I broke it. Because I was trying to debug what was going on with the state. That's why. Four, 6, 7. Now this is where things go wrong, but why? What? What? I mean, let's just try and get past the error, like just to hack it by so we can actually see what the value is. Why is it only happening on the 3rd gate? Like, that's so weird. How much time do I have? Okay, I'm still okay. So, 4, 6, 7, correct. 4, 6, 7, correct. Whoa! Why does that go to nil? Oh, are we indexing past the end of the table? Is that what's going on here? If we resume, does it crash? It eventually crashes. Alright, I'm starting to lose track of the little hacks I did to put it through, so I kind of want to get rid of them. Let's do this. Since speed equals 0, then little hack there so we can at least see what's going on. So actually it has nothing to do with this being a gate. We could have just had like an ordinary wire here and it would have still happened, I think. Okay, do this trick again. Do this again. Now we should be able to see stuff in the log. If I step, hey, cool. So sim reg 1. The tile offset should be the same for all of them. Oh yeah, that's just a gate. This state is 0. P3 equals 1. So that state goes to 4, as it should. State goes to 6, as it should. P3 equals 6. Who's setting P3 to 6? I think we found our problem. So over here in the driver function, wait, why is this here? Okay, this shouldn't have done anything, but it's now unnecessary. And now in the draw function, I would like to actually draw it. Please and thanks. I think we fixed it. I think this will fix it. So, put in one of these, put in one of these, and let's put a few more for good measure. Oops, put in one of these, do our trick. Okay, well, the buck seems to be stopping there, so we need to figure out why that's happening. I mean, we may as well look at the log, although I don't think it'll be that helpful. So simreg P3 equals 1. So one of these is not setting P3 of the other reg for some reason. Okay, what's that line I just deleted? Oh. I got confused there. Neighbor.state equals 1, so we don't need this. We almost fixed it. So now here we don't set it equal to the state. We set it to gstate and 1. Okay, now we should be okay. Okay, good. I think we did it. That's pretty slick. Let's make a little counter, because we can do that now. So let's just grab this as a clock and go down here. Right. No! We hit a post condition. Gate 8.3 unlisted net. Shoot. Shoot. We gotta figure this out. We gotta follow the DFS. Okay. What are the coordinates here? 0, 1. Okay. So we start the DFS at 1, 1. DFS at 1, 1. Neighbor 1 is net. Yes, it is. Add blah to coord list. DFS at 2, 1. Add blah to coordinates 3, 1, 4, 1. Go down 4, 2. DFS at 4, 2. Neighbor 1 is gate? I don't think that's true. Ah, I know why. I know why. I think in DFS yeah. I don't really understand exactly the problem, but I think this will fix it anyway. Yeah, okay. This seems to have done it. So now let's draw our, so let's give ourselves a little clock down here. Now we can make our slow clock a little bit nicer, although we don't really need a slow clock, do we? Because we can just turn up the speed. Man, this is getting very, very, very nice. So now, because we have setup and hold time, though, we do want some delay on the clock. So let's just do a clock like this. Oh. Oh, it's just really slow. Okay, I got scared for a second. It's a little slow still. Okay. This is our clock. Let's make a little counter. Now I'm going to do a what is it called? A ripple counter. Yeah, I'm going to do a ripple counter. Although these are latches, they're not flops. So let's start by making a flop with 2 latches. Oh, but we need to balance the clock. Oh, by the way, our drawing function is working, so that's nice. I was a little like, oh no, we got more bugs to fix. Oh, now what? Oh my goodness. Oh man, something is really, really wrong. Let's see if I can catch it. Oh, because of the simulation. Yeah, I don't want that though. So let's resume and just put this into single there. Gate 4.4 unlisted net. Why? I think I can maybe get this to happen with just something like this. Oh. What if I try doing the same thing I did before? So overriding it with a junction caused a problem? That's weird. But not erasing it? Oh, erasing it does cause a problem. That's what I thought. Oh, because it's the last coordinate of the net. I see. So if I erase it from here, the DFS finds it, but if I erase it from here, the DFS doesn't. Oh, I know. This is the initial case in the DFS. That's why. That's really, really annoying. I almost want to do, you know what? I'll change these as I see them. I just had a thought for something I could do to make this a little bit nicer. Is I can do O dot is component equals true. Or, yeah. We can do that. And then what we can do here is, I won't bother to go through and change all of these, but wherever I see them, I'll change them. So I'm actually a little confused. I thought it would be the initial case, but I don't even have an initial case for gates. Oh, it's over here. It's over what we call DFS when we're searching the neighbors. See here, found gate neighbor. It should be like this. If neighbor dot is component. That should fix that actually, I think. Yeah, good. Good. So now can we make our counter? Please and thanks. So speed 5 was actually pretty good for that. Oops. Actually, I think I like it better with the negator at the output. Like that. Cool. Now, let's start by trying to make a flip-flop with 2 latches. Now I need a delayed clock in one of these and the negated clock in the other. Like that. I think this works, actually. And actually I want its outputs to, so I need an AND gate here. An AND gate, I think, is just this. So I need this. Like that. So this is my D input, or no, this is my T input. So when it's 1, it should toggle on every cycle. So let's give ourselves a 1 here. That's not right. Actually, I don't think I want the delay here. The reason being, these two need to latch simultaneously. Well, let's just see what happens. Oh no, this is definitely not right. I think maybe I want an extra delay on this. No. I definitely need a delay on this one, but maybe I need an extra delay on it. Whoops. Like that. Actually, I never checked if the latching was working. Okay, I need to single step this. So this one is, oh, actually, I just realized right now, because I made it possible to move the cursor while you're single stepping. I can now point to things because it doesn't show my cursor in the OBS. How much time do I have? Another 30 minutes. Okay, we can do this. We can do this. Okay, now on this cycle, it's not latched, so it takes the value, but this one is latched, and therefore its state should, how come? I guess this doesn't matter, but I don't know. My cursor movement is not as accurate as it was when I'm single stepping. I'm not really sure why. Anyway, it doesn't matter. So now this gate here should not change, except it does. So I think something might be wrong with my lookup table. If not latch, then we allow it to update. Otherwise, it should stay exactly the same. All right, let's check the debug messages. I think I should be able to figure it out from the log. Simgate 9. Geez, I don't know what's what. Okay, let's just simplify this a little bit. Now we've only got one reg. Let's do our trick. I really wish you could press and hold in here, but whatever. Okay, now let's go in here and look in here. And so if I press X, that incorrectly transitions there. So let's see what there is to see in the log. sim reg. Lookup value equals 7. What? The state is 0. Oh, P4. Oh yeah, that's fine. Or. This is an or. Duh. Duh. Come on, I should know better than that. Oops. Should know better than that. That should fix it. I had a blip in my internet. I think it's back now. The funny thing is I heard someone shuffling around in the hallway. I wonder if they like jiggled the cables. There's no way, the cables are in the wall, but I'm just being silly. All right, anyway. So now I think it should just work. So this is now latched. So now even if I give it a 1 here, yeah, good. But if I were to unlatch it, yeah, okay, good. So now we have that. Now can I draw my counter? So many bugs to fix. One of these, one of these, one of these. Do, whoops, this. So this is my clock. Now, let's make a flip-flop. Actually, let me move this over 1 to the right. And I think I needed a delay 2. This just makes it a little more stable. Delay 1. Like that. I know. I think I needed delay 1. Okay, I think that does it. Then this loops around. We need an AND gate for the whoops, for the T flip flop, which I believe I did with just this. So now this comes in here. Whoops, in here like that. And now this input needs to be 1 if we want it to toggle. So let's try that. Very cool. So we've got a clock to Q of, we can count it actually now that we have single mode. So clock to Q is 1 cycle, 2 cycle. We have a clock to Q of 2 cycles for this flip-flop. Okay, let's put the speed to 1. Now what we can do is copy this exact same circuit. Copy and paste would be really nice. Even just to pick up and move something would be really nice. But, you know. So, I know. I need... Oh, yes, actually. Yeah, this is fine. This is fine. I don't need the enable... I don't need the enable on the second bit. So, we'll just write this around like that. But now this one we'll use for clock. Actually, I can make this a little more compact. Why not? because now the clock that this one uses is this over here. And I need to balance the clocks to both of them. So I need just a delay, and I need a negator. It's just a negator. Then we can do this. So our count value is, let's put the count value down here. Whoops. Whoops. Wait, how come I can't? What? What is going on here? Everything is connected. Okay, I messed everything up. This is our count value. Does that seem right? No, it doesn't. I have to think about why. Let's slow this down a little bit. Not too much, though, or else it'll be way too slow. So we see tick, tick. So this is going tick, tick. This is going tick, tick. So it's half as fast. Oh yeah, of course. This is a T flip. It should be a T flip flop. What am I doing? This really does need to be an AND gate. I think maybe like this. Maybe. I'm just guessing and checking now. Oh, wait, is that it? Nope, not quite. Let's try putting a delay in here. I mean, now I'm just getting desperate. Oh, and this should be an AND gate. Maybe I need to delay the clock. This is not working. It's not working. Okay, so making a counter is challenging. But my delay elements are working, so that's nice. We'll try the second bit of the counter some other day. At least we know the first bit is working. Cool, huh? All right, that's a result. I should start getting ready to go. Oops, save this. Git add gen that. Git add logisim. Let's check the diff just to make sure there's nothing weird in here. New file. Yeah, that's a little hack there, but it works. Well, we can change the reg to this is in place wire. I mean, yeah, I mean, why not? We can. So if n dot is component, and p dot is component. Oops. Okay. That's fine. That's fine. Yeah, I think I'm happy with that. I should have, yeah, you know, just whatever, like, just a quick thing to make sure I didn't break anything. Cool. Okay. Man, I should just delete this. FPGA.p8 was my first attempt at making a logic simulator. Full disclosure, this wasn't my first attempt, but this attempt is pretty much empty. There's like nothing in it. I can prove it to you. I just started drawing a couple of things. I don't even remember what I was drawing. And it does nothing. It just does nothing. So yeah, let's just get rid of that. It's just taking up space. I don't care about the disk space. I'm talking about screen space. Then a bunch of untitled stuff that I don't know what I'll do with. Sprite sheet. I don't know what that is. Anyway, let's gut punch. Oh no, we need to commit it first. -n. Bring up registers. Now we can gut punch it. Okay, job well done. As much as I would like to keep working on this, I can't. I instead have to go and do some annoying errands. Yeah, all right.